Okay, so now so we took off this lid which was placed here, and we took with this off, and we can now see the electronics inside the vehicle. So let me talk to you more about what's going on as of now, right now in this vehicle. So at the back, this is a huge gearbox here. What this gearbox does is that it has got a DC motor here. It's a thick DC motor here. This is a brushed DC motor. It has got 3 wires coming out of it. Normally DC motors have got only 2 wires coming out of it. This has got 3 wires. So the brown and the blue one are actually the power wires, one for positive and for negative. The third black wire is actually for suppression of noise. Because it is a thick motor, it will generate a lot of noise in the sense of electronic interferences. So what this black wire does is it has to be connected to the ground of the circuit, so that all those electrical noises can be dumped or can be synced into ground, and they don't actually interfere with the other digital electronics and other low voltage electronics which are generally present inside this circuit. And we don't need to dismantle the back portion because it has got a lot of gears. We don't want to open this, because once you open it, it actually opens up a Pandora box of gears, and if we don't understand the mechanics in detail, we may end up being not able to put it back together. What's important for us is that there are wires coming from the behind of this vehicle into the circuit, and we will sever these wires somewhere here, and we will reuse them in the new circuit. In the front, what you see here is this is another DC motor here, which has got a mechanical system here, and this mechanical system is then connected to this steel wire, and the steel wire then pulls or pushes the wheels towards left or right, and they do it for both the wheels. So both the wheels have got this wire which is connected to this motor, and to steer the vehicle, what this motor does is that either it turns left or turns right. In a lot of projects that other people have done, we have seen that they have used a servo motor which can turn clockwise or anti-clockwise by a certain angle, say 180 degree or 90 degrees. But I think even this DC motor is also fit for purpose, because we can either rotate it left or right using the DC controller that we spoke about earlier, and it should be able to do. If in case this doesn't work according to our expectation, what we will do is we will replace this motor here with a servo motor, and then we will have a better control and precision on the steering. It is also possible that even if the servo motor is not able to give us more precision, we may be replacing it with a stepper motor, which will give us a very accurate precision of how much we want to steer the vehicle left or right. But I think in the version 1 of our project, we will stick to the stock DC motor. Maybe the second version will have a servo motor, and a third version of it will have a stepper motor. But right now, this is what we are going ahead with. In terms of the existing electronics, we can see here that the front DC motor is connected to this circuit. So what this circuit does here is, so there's the antenna also connected to this circuit. So what this circuit currently does, it receives the radio frequency signal from the remote, and then there is an integrated circuit here. This circuit understands the radio signal, and then it sends the instructions to these there are 4 transistors here. What these transistors do is that they together form a dual H bridge circuit, which is used to drive the 2 motors, one at the back and one at the front. So what we are going to do is we are going to take this circuit out now, because we don't need this circuit. And what we will do, we will replace this circuit with a circuit of our own. So the circuit that we are going to put will now comprise of small Adruino Nano board and one of these DC motor controller. So these two devices will basically replace the existing circuit, and this Adruino, it will receive the instructions from Raspberry Pi, and those instructions will tell the Adruino to either move the vehicle forward, back, left, right, and even also tell Adruino on the speed as well. So how fast the vehicle should move. So we should be able to control the speed as well. So all these existing electronics will now be replaced with just two of these PCBs, and then we will connect the Raspberry Pi. So now we'll start with disconnecting the wires. So first we cut the front DC motor wires. So cut from here, somewhere here. Okay, so the front DC motor wire is now cut. Let's cut the rear. Let's cut the rear DC motor wire also. So let's see. So let's cut the brown wire from here. Okay, so one wire is out. Let's take the blue wire. So cut the blue wire also from. Yeah, good. Let's take the noise suppression wire also out. So now all the three wires of the rear motor are separated from the circuit. So we move them at the back. Next is to cut the so this is a terminal on which a battery is connected below the chassis. So now we will cut the power also from the circuit. Can you cut the black wire? So now he's cutting the black wire. So that's the ground voltage or 0 volt. So that is now separate. And now let's cut the positive wire also. So now the terminal is also gone. What is left now is the antenna here. So we will cut the antenna here. Great. So now we can see that the circuit in itself is completely disconnected. There is just one screw which is holding it. So we will unscrew this one also, and hopefully we should get full access to the controller card. And I'll also talk a little detail about the electronics here. Yeah, so it has come out now. So let's talk about existing circuit also. So you can see that this PCB has got an on-off switch. Our vehicle will also have an on-off switch. So we will either put a new switch, something of similar sort, and there was a switch for switching the channels. Our new vehicle will not have the channel switcher, so this is not required in our new design. So these are the power ICs, power transistors, which were driving the motors. Now, so these transistors are now being replaced with this integrated circuit, which also has got transistors inside, but it's an integrated device which is capable of powering two DC motors through one device, or it can power one servo motor. So we are using two DC motors, so we will use one such device. So this device here basically does the work of 4 transistors here, 1 2 3 4, right? So these four transistors are together forming a dual H bridge, and the modern design has got that dual H bridge implemented inside this one integrated circuit. Cool. And besides that, we will hopefully not require this device, but we will preserve this electronics for any future project. So next, what we will do is we'll try to just roughly place our devices on the chassis to understand how they will fit the overall circuit. So we come back to our bare chassis now. I think it has got plenty of space now for us to put things together. So I think somewhere here we will mount the DC controller like this. It fits perfectly, and somewhere here we will put the Adruino Nano board. We will have to maybe use some hot glue to kind of stabilize this PCB here, and then we will wire it together. But right now we can see that our Adruino Nano doesn't have the connecting pins soldered. So first we will solder all the connecting pins, and then we will start doing the wires using the male female jumper wires. So we will need wires like this, which are available. You can take as many as you want out of this bunch, and then you can use them to wire. There are wires like this one is what is this type wire? Male to male. This one is
female to female.
And what is the third one you have? This is a female to male. Yeah. So depending on where your circuit is originates and where it ends, you will have to use one of these three types of vehicles. I think we are ready. So one other thing is that this chassis has got a lot of strength otherwise, and good construction. So no other engineering required as such as far as mechanics is concerned. It should be able to endure some rough patches on the street. Otherwise, I think the overall construction is quite rugged. Whatever had to come off had already come off during our initial road test. So what we are left with now is a robust chassis. We may have to also put one sort of a plastic sheet on top of this to basically mount other electronics on top of this. But I think right now we are good to get into the next step. So in the next step, what we will do is we will start wiring the DC motors. So we will wire the rear DC motor, we will wire the front DC motor to this DC controller, and we will wire the Adruino board to the DC controller. And then what we will do is we will put some test programs in Adruino to just do a check on the basic mechanics. So once the wiring is done, what we will do is we will check whether we are able to move the rear wheels front and back. We will check whether we are able to control the front wheels left and right. Right now the angle of turn is not important, but what we will do is either left or right. And the third thing is whether we are able to control the speed of the rear wheels. That's also very important.